Welcome to the channel. Our today's topic of discussion is acceleration measurement test for motorcycles, scooters, and power operated cycles. We have already discussed the prerequisites, preparations, and protocols applicable to the standard testing procedures for complete vehicles, that is, motorcycles, scooters, auto rickshaws, and power operated cycles. Here are two situations for acceleration test. Number one is acceleration from the standing start, and number two is acceleration from the running start. This infographics explain the complete testing procedure for the case A, that is acceleration from the standing start. The acceleration will be calculated by A is equal to 2s divided by t square, where A is average acceleration, that is meter per second square, s is measured distance in meter, t is time in seconds. Now we shall go into the details of this test. Case A, acceleration from the standing start. It means the motorcycle begins from a complete stop, that is zero speed. The bike is stationary at the start of the line. When the test begins, the rider accelerates from zero speed, shifting gears as needed. Its purpose is to measure how quickly the motor vehicle can get up to speed from a dead stop. Its common use is it is to evaluate initial launching performance, such as in traffic or drag racing starts. It includes the time and effort it takes to overcome inertia and get moving. The drag racing being referred here is a type of motor racing in which two vehicles compete to see who can accelerate the fastest over a short straight distance, usually quarter of a mile or one-eighth of a mile. The test objective is to evaluate acceleration performance and calculate the average accelerations over a defined distance. The test procedure includes begin the test on a designated test course by starting in low gear. Accelerate smoothly and shift up through the gears at their optimal points. Measure the time taken to cover each specified distance and record the speed at the end of the test run. The test should begin with foremost part of the vehicle's front wheel positioned 0.5 meters behind the designated zero point on the test course. Measuring points will be as follows. For motorcycle less than 125 cc, the measuring points shall be at a distance of 50 meters, 100 meters, and 200 meters. For motor vehicles more than 125 cc, the measuring mark shall be 100 meters, 200 meters, and 400 meters. When the time is recorded, the following formula is used to calculate the average accelerations. average acceleration A is equal to 2h divided by d square, where A is average acceleration in meter per second square, s is the distance covered in meter, t is the time taken to cover that particular distance. For example, a motorcycle starts from the rest and covers a distance of 200 meters as specified before in 10 seconds. During this test, we use the formula A is equal to 2s divided by t square, where s in this case is 200 meters, t is 10 seconds. By substituting the values of s and t, we get the value of average acceleration as 4 meter per second square. Therefore, the average acceleration of the motorcycle is 4 meter per second square. The speed measurement area shall be 2 meter stretch with the test course endpoint at its center. It is to ensure that the rider is following the protocols applicable to this test. This infographics explain the details in respect of acceleration from the standing start, that is test setup and starting position, test procedure, distance markers, acceleration calculation, and finally, rounding guidelines. Important notes regarding this test are: ensure proper calibration of timing and speed measurement devices. Number two, perform multiple runs to ensure data reliability. Number three, all measurements must be taken under consistent environmental and road surface conditions. All other factors related to environment should also be recorded because the real world acceleration is affected by the wind, especially headwind or the tailwind, surface texture and the grip of the test course, rider weight, and tire pressure. Since acceleration tests at a high speed can be hazardous, it would be a good practice to remind testers about wearing proper safety gear. The management should be ready for any medical emergency and any emergency stop planning. To ensure the accuracy of the test, it is recommended that digital recording tools should be used. Consider use of high-speed telemetry or GPS-based data logging systems. By high-speed telemetry, we mean the real-time transmission of data at a very high rate from a remote or moving system, like a vehicle, aircraft, or any other machinery, to a receiving station for monitoring, analysis, and control. Now we come to the second situation, that is acceleration from the running start. This infographics includes the test procedure and the measurement points. Now let us come to the detail. Unlike the case A, that is acceleration from the standing start, in case of running start, the motorcycle already has some initial speed at the moment the test measurement starts. The bike approaches the test section at a steady predetermined speed, that is cruising speed, the rider then accelerates from that speed, shifting gears optimally. The purpose is to measure acceleration performance while already in motion, focusing on how quickly the bike can increase speed from a moving baseline. Its common use is it's useful for real world scenarios like overtaking or merging into traffic. Its focus is on power and responsiveness as speed. Let us compare the two situations. That is acceleration test with standing start versus acceleration test with the running start. So initial speed in case of standing start is 0 meter per second, whereas in running start it would be more than 0 meter per second. The focus in case of standing start is launch capability from stop. In case of running start is acceleration while moving. In case of standing start, initial speed is 0. In case of running start, the motor vehicle is approaching at a constant speed. In case of standing start, the practical scenario is traffic lights, drag race start. And in case of running start is overtaking, and merging into the traffic. The acceleration from running start. This test evaluates the acceleration performance of a motor vehicle when entering the course at a predetermined running speed, simulating overtaking or high-speed maneuvering conditions. Its objective is to measure average acceleration over a set distance when the motorcycle enters the test course at a constant pre-specified speed. The test procedure is the step-by-step test procedure is approach the test course at a constant initial speed, that is 20 km or 30 km per hour. Use either the top gear or one gear below top unless otherwise specified. As the motorcycle enters the test course, apply full throttle or most effective accelerations. Record the exact time the vehicle enters the test course and the time it passes each measuring points, each distance marker that we have already defined, that is 50 meters, 100 meters, and 200 meters. Ensure proper throttle control to maximize acceleration performance without wheel spin or gear lag. Measuring points or recommended measuring points are 50 meters, 100 meters, 200 meters. According to the protocol of the test, the initial speed standards are 20 kilometers per hour plus minus 1 kilometers per hour or 30 kilometers per hour plus minus 1.5 kilometer per hour. Other speed may also be specified depending upon the test requirement. Speed measurement locations. Measure the initial speed exactly 4 meters before the motorcycle enters the test course. This point is labeled as point O. or origin. Now coming to the formula for calculation of average accelerations. We know that in basic kinematics, when a body starts from some initial speed v, the displacement s over time t, or the distance covered in time t, under constant acceleration is given by s is equal to vt plus half at square, or s minus vt is equal to half at square. If we multiply left and right side by 2, then we get 2 into s minus vt is equal to at square. Now divide both the sides by t square, we get a is equal to 2 s minus vt divided by t square, where a is average acceleration in meter per second square, s is distance covered in meter, t is time taken in second, and v is the initial speed at the point of origin, that is point O. Let us consider example for the case acceleration from the running start. In case of running start, the motor vehicle enter at a predetermined speed. For example, it is acting at 54 km per hour, that is 15 meter per second. The distance covered is 200 meters. The time taken to cover this distance is 10 seconds. Then average acceleration is equal to 2 into 200 minus 15 into 10 divided by 10 square is equal to 2 into 200 minus 150 divided by 100 is equal to 2 into 50 divided by 100 is equal to 100 by 100, or is equal to 1 meter per second square. The average acceleration therefore is 1 meter per second square. Now, if you remember that in case A, that is the acceleration from the standing start, the formula used was A is equal to 2s divided by t square. So that formula was derived because in that case the value of initial speed is 0. So if we put v is equal to 0 in this equation, then we get a is equal to 2 into s minus 0 divided by t square. That is, a is equal to 2s by t square. That is the same formula we used in previous case, that is in case A, to calculate average acceleration with a standing start, that is with a dead stop. For the best practices to conduct these tests, to please ensure to use precise digital timing and GPS devices, etc., to measure time and speed accurately. Perform these tests at least 3 times per distance to ensure repeatability and to calculate the mean value. Ensure flat, dry surface and consistent ambient conditions for all the runs for the purpose of comparison. Maintain vehicle load, rider weight, and tire conditions consistent across all the tests. With this, we conclude our today's discussion on the subject of acceleration test. Please do drop your comments and share your experience. Our next topic of discussion will be coasting test. Thank you and thank you very much.